Hi, welcome to the next lesson of this data cleansing module. Here we are going to focus on schemas. In simple terms, schema is a metadata that describes the data you are processing, and believe me that knowing what you are processing, what you are working on will simplify your life a lot. Because imagine that instead of spending 1 or 2 days on exploring the data set, on analyzing the different values, different types, here you have a specific direct information on the values, on the types, on different constraints. So you can imagine that if the value can be only positive in your processing job, you will not necessarily implement any fancy validation rule for that, and it will generally make all things easier. And to introduce these schemas, we need to recall different data types. So the first type is structured, meaning that there is always a data description that is enforced, and that's the ideal scenario. The second scenario is semi-structured, where we have some description for the data, so some schema, but unfortunately this schema is not enforced. And finally, we have the unstructured data like images, like text, anything that cannot be described by the schema. So to sum up, described by the schema, schema enforced, described by the schema, schema is not enforced, like for example for JSON, and finally unstructured, where there is no schema at all, but you can annotate it somehow with some metadata, some tags, but it will not necessarily replace the schema. It will be more local for each file, for each picture, for example. And what is the composition of a schema? So we have field, attributes, and columns that define, so that these are different names for the same thing that defines the composition of the data set. So we can have an attribute A, attribute B, attribute C. It can be called field A, field E, B, field C, or column A, column B, column C, depending on the data source and the naming conventions of the data source. Next to it, we have the type. The type is a kind of field category, meaning that it defines what is expected type of category of given attribute, given field, given column, meaning that here you can say that, okay, column E is a string, column B is an integer, column C is an array of integers, and it will also simplify your data processing logic a lot, because typically you will be able to map your input data source directly to something much more consistent from this schema standpoint in your processing code. And finally, there is also validation rules. So the constraints, as I said before, you can define one field as being only with positive values. You can do other things, like for example define the max length of arrays, or any other constraints you want. And again, it will also simplify the data processing logic, because you will not need to repeat these rules in your job. And for example, here we have a sample schema where the field is a first name of type string, and the rule is that it cannot be null, and for the field age it's an integer, and it cannot be lower than 0. It cannot be 0 or lower, sorry. But schema is not shiny and rosy. There are some pros and cons depending on who you ask. The first pro is data integrity. Of course, you have static schema, static data description you can rely on in your data processing, in your machine learning, in your analytics pipelines. So it simplifies the whole system, the whole data usage by a lot. But on the other hand, there is also some dilemmas, like for example, new column dilemma. And the question is, when you add a new column to your data, is whether I should regenerate the data set or not. Whereas when you don't have any schema, or you have semi-structured data with schema, you simply add it, you don't necessarily ask you this question. And there is also some specificity about semi-structured data. As I said, it has some schema, but unlike the schema for the structured data, is never enforced, meaning that even though in our example we have first name attribute, we can call it either in full uppercase or we can maybe use camel case for that. There is no really the constraint for that part. There is no constraint for the type either, because instead of using a string, we could use a struct. So give, for example, a name struct and structure, or structure composed of value and maybe type. So it will be value will be the first name and the type will be string. So there's always different ways to break this type rule. And finally, there is not validation at all. In the schema is somehow external, and you can apply it towards your rows. Here it's a little bit different. Schema is included in the rows. There is not necessarily a way to apply it to each row unless you have this implemented as a part of your data processing job explicitly. There is also a difference from the application standpoint. So first, for the structured data, the application can complete the constraints you are defined in the schema. For example, it can be very challenging to define a validation rule relying on some external web services, whereas in your data processing code you can do that much more easily, and it will be a bit more both worlds can work together. On the other hand, when you have some structured data, all the constraints you must implement in your application logic alongside the name and type controls. So all this to say that schema is a big game changer if you have it in your data processing pipelines, in your data systems. But on the other hand, it's not always reliable, and you may need to write much more or less code to respect all this metadata describing your data. Thanks for watching, and see you in the next lesson.